Hi, so today I'm going to introduce some vocabulary words in this freshwater unit to you. They are all here, so you can have a quick look at them. Now let's get started. The first word that I'm going to talk about is freshwater. Freshwater is relatively pure water with few dissolved salts. For enrichment, most freshwater is found in glaciers, underground aquifers, and ice caps. Only 2.5% of Earth's water is freshwater. So this diagram here shows an example of freshwater. It is a lake. Now let's look at the next word, surface water. The definition of surface water is water existed on the Earth's surface. So lakes, rivers, and streams are examples of surface water. And this picture is an example of surface water. It is the Nile River. Now let's move on to the groundwater. Groundwater is water located under the Earth's surface, held within pores in soil or rock. Enrichment. Groundwater is commonly used for public water supplies. So this picture shows the groundwater here. The next word is aquifer. Aquifer is porous and sponge-like formations of rock, sand, or gravel that hold water. Enrichment. Aquifers are categorized into confined aquifers and unconfined aquifers, which I will discuss them in the next slide. And this picture shows the Ogallala Aquifer, which is the largest aquifer in the world. Now let's talk about confined aquifer. Confined aquifer is formed when a porous water-bearing layer of rock, sand, or gravel is trapped between upper and lower layers of less permeable substrate. So in this diagram here, you can see confined aquifer here. So it is located between the upper layer and the lower layer. Confined aquifers are also called artesian aquifers. So how does confined aquifer differ from unconfined aquifer? Now let's look at it. Unconfined aquifer is any aquifer that has no impermeable upper layer to confine it. So its water is under less pressure and can be recharged by surface water. So as you can see in this diagram, the unconfined aquifer is here. So it has the lower layer, but it doesn't have the upper layer to confine it. So the height of the top surface of an unconfined aquifer is free to fluctuate with rainwater. Now let's move on to the water table. The definition of water table is the boundary between an aquifer's upper layer, which is the zone of aeration, and lower layer, which is the zone of saturation. So this diagram here shows the water table. This line here, this line represents the water table. So it's the boundary between this area, which is the zone of aeration, and also this area, which is the zone of saturation. Enrichment. Water table changes when the hydrological system changes. So for example, the water table falls with droughts because obviously there is less water during droughts, and the water table rises with heavy precipitation because there is more water on the surface, so the water table rises. Now let's look at the watershed. Watershed is the area of land drained by a river and all its tributaries. So this diagram here shows a watershed. A watershed includes the river and also the area beside the tributaries. Enrichment. Watersheds are also called basins and drainages. People living in the watersheds strongly rely on them for drinking water. Now let's look at floodplain. Floodplains are areas nearest a river's course. They are flooded periodically within the river's floodplain. So the picture here shows a floodplain. Due to frequent flooding, the soils in floodplains are fertile and good for agriculture. So as you can see here, beside the river here is the floodplain, and there is many crops and farms here, so it is good for agriculture. Now let's look at wetlands. Wetlands are systems that soil is saturated with water, and the water is shallow standing water with ample plants. So this picture shows what a wetland is. Being more specifically, it is a swamp. So wetlands include many types of characteristics, including marshes, swamps, bogs, and vernal pools. So this picture is a swamp. Wetlands are valuable for wildlife. So in swamps, crocodiles are common. Now let's look at consumptive use. Consumptive use is when people use water from an aquifer or surface water body and do not return it. So people's primary consumptive use of water is for irrigation. So this picture here shows the irrigation. It is one of the examples of consumptive use. Now, its opposite is non-consumptive use, which is when people use water temporarily from an aquifer or surface water body. So one example of non-consumptive use is when people use water to generate electricity at hydroelectric dams. So when people use water from the dams, it is the non-consumptive use, because people do return the water to the dam. Now let's look at sinkholes. Sinkholes form when land sinks abruptly, and also sinkholes are areas where the ground gives way with little warning. So this picture here shows after a sinkhole. So this is the sinkhole here, and people are repairing the damages. Sinkholes may cause buildings to lean and destroy people's houses and also other public facilities. Now let's look at dams. Dams are any obstructions placed in a river or stream to block its flow. So the largest dam in the world is the Three Gorges Dam in China. This picture shows the Three Gorges Dam, and it's placed on the Yangtze River in China. Now let's look at reservoirs. Reservoirs are artificial lakes that store water for human use. So in this diagram here, a reservoir is built on a farm and beside the crops, so people can use water from this reservoir to irrigate their plants. Enrichment. Reservoirs also serve other purposes. For example, they are used for boating, fishing, and other forms of recreation. Now let's look at the final word for today. It is desalination. Desalination is the process that removes salt from seawater or other water with marginal quality. So this picture here shows the process of desalination. First, we have salt water or dirty water. Then people use heat to increase the temperature of the salt water, so the water will evaporate and the salt particles in it will remove at the bottom. And the evaporated water will go up in the form of gas, and when it reaches this step here, it is cooling. So people decrease the temperature of the gas, so the gas will condense and become water again and flow to this area here. This area is where we have fresh water and there is no salt in it. So this is how the desalination process works. For enrichment, there are about 15,000 plants producing desalinated water, most in the Middle East and North Africa. Note that the largest plants is in Saudi Arabia. So that's all for today. Thanks for watching.